this video is for the no calculator portion of your unit test Honors Algebra 2 review over square root functions. So we'll start with some multiple choice problems here, and then we'll work on some free response. So the first one says, which equation below describes the function graph to the right? Well, you need to be able to identify the transformations that have taken place for the graph. First thing I notice when I look at this is that my graph was reflected over the y-axis. Now, if you're having trouble here, you need to make sure that you understand the square root function. Remember that the parent function starts at the origin, goes out to 1, 1, 4, 2, and 9, 3. So if I know that's the parent function, I know that my new graph has been reflected over the y-axis, and it looks like the graph was shifted up 1. Well, reflecting over the y-axis is when you have a negative under the square root. So I can immediately eliminate a and b. C and D both have a negative under the square root, but I need to remember that up 1 is a plus 1 outside of the square root. So C is my answer. All right, next problem here. 6 and 7 go together. It says, which of the following describes the domain and range of the function? You're not allowed to use your calculator. That was the typo right there. No calculator portion. So you need to understand the function without. What I would do is remember to find the domain of a function. You take what's under the radical, which here is 2x plus 8, your radicand, and you set it greater than or equal to 0. We're going to do a lot of that in a minute. You solve this for x. So I subtract 8. I get 2x is greater than or equal to negative 8, and divide by 2. That means that my domain, or all the x's, greater than or equal to negative 4. All of these problems are in interval notation. I can automatically eliminate C and D because the domains don't have a negative 4 in them. But I need to make sure that my domain here, all the x's that are greater than or equal to, mean you start at negative 4 and you go to infinity, which leaves A and D both as viable options. So I have to talk about my range. In order to talk about range, we're not going to do a ton with range, not with a calculator or a graph, but we should be able to look at this original function and notice that it had a vertical stretch right here, but at the end of the function, there's no plus or minus. So this graph doesn't go up and down, which means it's staying at the origin. So its range is starting from 0 in D. All right, in A, that range would have meant that our graph was shifted up 8, and that's not the case here. Now, the question in 7 says, which of the following values of x is not in the domain from number 6? So I look at my domain, all the x's greater than or equal to negative 4. I want to know which of those numbers is not greater than or equal to negative 4. Well, 0 is definitely bigger than negative 4. And if you need to, think about a number line here. My domain, drawn a different color, are all these numbers to the right of negative 4. 0 is in that domain, so that's not our answer. Negative 5 is to the left. That's not in the domain, so that would be one we circle. 4 is in the domain, and so is positive 5. So negative 5 is the value that is not greater than or equal to negative 4. All right, last multiple choice question here. Choose the equation below that has undergone a vertical stretch by 3. So let's look at these. Vertical stretch by 3. The 3 is going outside of the radical. So we have A and C. B is not a vertical stretch, neither is D. And reflection over the y-axis. So that means just like the problem a couple ago, the negative is under the square root and down 2, which does match C here. In A, this is a reflection over the x-axis. So that's not what we want. All right, let's talk about domain for a few minutes. For these domain problems, you're going to find the domain by hand by setting up an inequality and solving, and then sketching a picture of the what the graph looks like. All right, so I need to take, when I'm finding the domain of a square root function, square root of 5x plus 6, I take the radicand, just like above, and set it greater than or equal to 0. I solve this by subtracting 6 from both sides. You have 5x is greater than or equal to negative 6, and then I'm going to divide by 5. That tells me that my domain is all the x's greater than or equal to negative 6 over 5. Now I'm going to write that in set builder notation, so we need the curly brackets, and our domain is all the x's such that x is greater than or equal to negative 6 over 5. Now to sketch this graph, it's just a rough idea. So we know negative 6 over 5 is just about negative 1, negative 1.2. So we'll put a dot there. And we want all the x's that are greater than. So since we know what a square root function looks like, we can sketch that our graph is probably going to look like this to the right. All right, now let's look at B. B is a very similar problem. If I have 28 minus 7x, I set that radicand greater than or equal to 0, and I'm going to solve it for x. So I'll subtract 28 and get negative 7x is greater than or equal to negative 28. Now here I divide by a negative 7, and when I divide an inequality by a negative number, the sign flips. So my domain here is all the x's such that x is less than or equal to 4. Right? Only numbers 4 or smaller are going to work for that domain. So when I sketch the graph, I put my value at 4, my x-intercept, but I want all the x's smaller, so that's to the left, so my square root function is going to look like that. All right, C and D. A little bit more work here. Right? That radical should extend over top of the whole thing. Now, these are the problems where we said you have to set up your quadratic inequalities in order to actually sketch the picture and define your domain. Okay, so I take what's underneath the radical, my radicand, and set it greater than or equal to 0. Now, in order to find my domain here, I actually need to factor the left-hand side. That left-hand side is going to factor to be x plus 8 times x minus 3. Now, I want to know where that quadratic is greater than or equal to 0. So in order to do that, I'm going to use that quadratic inequality method from our last unit. I know that my x-intercepts of this quadratic from the zero product law will be at negative 8 and positive 3. So if I sketch this graph, I'm going to sketch a parabola that's opening up because our quadratic is positive, going through those two x-intercepts. And I want to know where I am greater than or equal to 0, which is these two tails of my quadratic equation. So what this does for me is it tells me actually what my domain is, because remember, I want to know where the quadratic is greater than or equal to 0. Well, I have all the x's here to get this left tail that are less than or equal to negative 8, or my x can be in the part of the equation where x is greater than or equal to 3. So I have two domains because I have two portions, or I'm sorry, one domain with two parts. Well, when I sketch this, I put x-intercepts, dots at both of my x-intercepts. My arrows actually, for the left one here, has to go out to the left because all those x's are less than or equal to negative 8. And on the other side, I have to go to the right. Now what this means, in case you're wondering, is say I take x equals 0 right here in the middle. That's not in my domain, but it's also not under the graph. Say I were to put x equals 0 into this equation. So I'd have 0 squared plus 5 times 0 minus 24. Well, what that would give me is the square root of negative 24, which is not a real number. It's an imaginary number. So because I did not get a value that was greater than or equal to 0 under my square root, that's why 0 is not in the domain. One more problem, very similar. Square root of negative 6x squared plus 42x. I take the radicand, and I set it greater than or equal to 0. I'm going to factor again here This time I'm factoring by GCX. So I'm going to pull out a negative 6x and be left with x minus 7. Now again, when I set up my quadratic inequality, I need to know where are the x-intercepts. So this negative 6x, when I set it equal to 0, gives me an x-intercept at 0. The other x-intercept looks to be at 7. Now here's the tricky part. When I graph this quadratic, my leading coefficient is negative, so the parabola opens upside down. So the portion of my graph that is greater than or equal to 0 is just this part right here. There's one portion of my graph that's greater than or equal to 0. So when I write the domain, I want all the x's that are in between 0 and 7. So I write my inequality as one compound inequality. What that looks like when I graph this is that I want to graph all the x's in between those two values, which actually ends up being a semicircle. So you need to be careful with what your leading coefficient is so that you can write your correct domain, understanding the way the parabola was sketched. All right, we're going to move on to the next ones here. All right, for these next three problems, we need to list the transformations that have happened to the square root function and then graph the square root function on the right. So the first one is g of x equals negative 2x, or I'm sorry, negative the square root of 2x plus 5. So when I look at the transformations here, I start on the left with the negative out in front. The negative out in front means that you've reflected over the x-axis. The 2 on the inside, remember, is a horizontal change. And when you have the value of 2, that's actually a horizontal compression by 1/2. You take the reciprocal of the 2. And then the plus 5 means that you move the graph up 5 units. Now, in order to graph this, remember, you need to know the parent function. So for the first graph, I'm actually going to graph the parent function for you so we can reference it. So here's 0, 0, 1, 1, 4, 2, and 9, 3. So you need to know those points on the parent function here in order to graph a transformation. So I'm going to graph a transformation in a different color. When I start at the origin, if I reflect it over the x-axis, it does not change position. Neither does compressing by 1/2. Moving it up 5, however, does move that point to the 0.05. Now, here's where we start to have some changes. In 1, 1, a reflector over the x-axis flips us to underneath the axis here. Horizontal compression changes the x values. So if I'm at the x value of 1, horizontally compressing that brings me to the x value of 1/2, negative 1. And then you move that up 5, which would be this point right here. So it's squeezed in there, but you're at 1/2, 4 is the point. All right, now at 4, 2, I reflect that over the x-axis. It brings me underneath here. Horizontally compressing that value of 4 brings me into the x of 2, negative 2, and up 5. So you'll be at the point 2, 3. All right, the last one here, 9, 3. I reflect that over the x-axis to 9, negative 3. Horizontal compression brings me to 4.5, negative 3, and up 5, which would be at 4.5, 2. All right, so my new graph, when I reflect it, compress it, and move it up, looks like this. All right, so again, if it helps you, you can graph the parent function on this grid here. So I'll do it just for reference because I think it helps some of you, but you do not have to graph the parent function. All right, so on this graph, I have the square root of x minus 3 plus 1. Well, the minus under the radical is moving your graph to the right, 3, and the plus 1 means you move up 1. So this one should be pretty straightforward. Once I take the point here at the origin, I move it to the right, 3, up 1, there's my new point. So this one, I don't have any stretches, I don't have any compressions, I'm just going to move up right 3 and up 1, which should give me that new pink graph. Forgot to do the domain and range. I'll come back to those after I do all the graphing. All right, finally in C, I have 3 times the square root of negative x minus 7. The 3 in front of the entire equation is a vertical stretch by 3. The negative under the square root is a reflection over the y-axis. And the minus 7 means you're going to then move down 7. So again, let's start. I'll put my parent function on here so that we can use it as a guide. And we're going to start by vertically stretching this graph by 3. So vertical stretches changes your graph by multiplying the y value by 3. So when I started my origin, when I multiply that y value of 0 by 3, it doesn't move. It also doesn't move when I reflect it over the y-axis, but I can move it down 7. All right, the point 1, 1. When I vertically stretch by 3, the y value of 1 moves up to 1, 3. Reflect over the y-axis is now at negative 1, 3. Down 7 would be at negative 1, negative 4. 4, 2, I stretch it by 3, so the 2 value gets multiplied by 3 to be at 4, 6. I flip it over the y-axis to negative 4, 6, and down 7. Negative 4 and negative 1. All right, last one here. 9, 3. I multiply the 3, the y value, by 3 to be up to 9, 9. I reflect it over the y-axis to be negative 9, 9, and go down 7 to negative 9, 2. So that pink graph right there is your transformed graph. Now, if you're working with domain and range for these graphs, domain, we're writing all these in interval notation, it says in the direction. So my domain here for this purple graph, I work left to right. Domain is the x's. The leftmost x value on that purple graph is at 0. It has a square bracket because that point is included. The arrow means that the graph goes forever to the right towards infinity. Now range are the y's. I start on the bottom, and on the bottom of my purple graph I have an arrow, which means that graph is coming from negative infinity, and it comes up to the y value of 5. Okay, that would be your range. In B here, my domain, the farthest to the left x value this time is at 3, and it goes until infinity. Now for my y's, the lowest y happens at 1, and then my arrow goes up to infinity. All right, domain in the last one. I have an arrow on the left this time, which means my graph comes from negative infinity and stops here at 0. Now the lowest y I have is at negative 7, and the arrow goes up forever towards infinity. All right, almost done. We now have to take the transformations from the pictures and write the equations. Okay, so again, it's just like the last problem. You need to graph the parent function for the square root here in order to see what the transformations are. That's definitely okay. All right, so this first graph, it doesn't look like we have any vertical or horizontal stretch, but we do move to the right 2 and down 1. So that looks like it's it. So when I write my equation here, moving to the right goes underneath the square root. You'll have an x. Right is minus 2. And down 1 is outside the square root. You have a minus 1. For B, again, let me draw my parent function here so you can see. Now notice, on my parent function, the first point is out 1, up 1. Okay? When I look at the first point on my new graph here, I go out 1, down 2. So since I'm going out and up 2, this is going to be a vertical stretch by 2. My graph is upside down, so it was reflected over the x-axis, and it looks like we went up 4 units. So to write this equation, The vertical stretch comes first, so you have your 2. Now reflected over the x-axis also comes in front of the square root, so I'll make that a -2 square root of x, and the up 4 is outside of the radical. There'll be a +4 on the end. All right, last two, we're still writing equations, but this time just from a description. All right, I have a vertical compression by 1/4. Vertical compressions always happen outside of the square root, so I'll start with a 1/4. Reflecting over the y-axis comes underneath the radical with a negative, and up 6 gets popped on the end. Now, if I reflect over the x-axis, I'm going to have a negative out in front. A horizontal compression goes under the radical, and remember, the compression, you take the reciprocal of what you're compressing by. So if I compress by 1/3, the reciprocal of that is 3 for my x, and then up 1 would be +1 on the end. All right, that's it for the videos for the review. If you have other questions on your review, ask your teachers or check the key that's posted on Canvas for help.